Hey folks, here we are with Ben from MP Antenna, the makers of H Antenna, to clear up a couple of RF confusion points in the world of helium. So Ben, start off by saying welcome. Thanks for coming on.
No, thanks for having me yet again. These are fun. The more questions we get in, the more we kind of figure out to try and help people understand more, the better we all off are. So
yeah, let's start off with one of the confusing points of just kind of this POC V11 and V10 and what the switch was and what's actually happening is and we'll just talk about US miners. I know that America isn't the only country in the world, but this just makes the math easy. Let's say that the US miners are pushing out 27 dBm, decibel milliwatts. And then you put an antenna on there that has a higher gain. So that increases your EIRP, your incidence of, effective incidence radiate, whatever it is, the strength of that signal going out. We'll keep it pretty clean. And then that gets received by another hotspot, and they translate that into, or there's an RSSI it gets received at, a received signal strength indicator it gets received at, and that hotspot, if it has a hotter antenna, can receive at a higher sensitivity. Does that all sound right so far?
Yeah, no, it sounds pretty accurate. And a lot of things that I've seen going around Discord, Reddit, and all the other platforms is that it's meant to hurt or damage people that are trying to earn more. Everybody wants to have more witnesses. Everybody wants to earn more HNT, and thinks that this was deliberate to disable people from earning more. And what people don't know is anything that's unlicensed, like in the ISM band that we're using with Helium, that also incorporates 2.4 gigahertz and 5 gigahertz, like in your Wi-Fi routers or anything unlicensed, and they're all subject to the same rules. The easiest way to look at this and understand that is let's say back in, I'll just throw it out there, like 2002, a lot of your Wi-Fi routers you could disable, or not disable, you could change out your Wi-Fi antennas for more optimized antennas, which are higher gain, which would reach further, so on and so forth. Almost every single Wi-Fi router you see in the market today, you can't take off the antennas. And they've learned to make that more, a way to make them legal for the FCC is they don't allow you to change the antennas anymore. So it isn't subject just to helium. It's across the board. It's across the world. Don't take it personally. It's just something that we have to adhere to.
Yep. And then there was a point of confusion that you had that we were just discussing. Let's get into that. Tell me what you saw was the confusion, and maybe we'll walk through that together.
The confusion of being what makes the transmission power get reduced if it does get reduced. A lot of people are saying you cannot go above a certain dBi antenna, which is true, but also not true. There's a lot of murky areas in RF and with this whole EIRP thing in POC 11. Let's say, to keep it simple, let's say you just had a 9 dBi antenna, which is a higher gain antenna, and you were 2 miles away from whatever is witnessing you. When that RSSI is heard, it's not so much that it's being reduced off of the RSSI if it's too hot or too good. It's whatever you're actually putting into the app that is negating the power, lowering the power. So if you have a 9 dBi antenna and your RSSI is going to be, let's say, a neg 68, when they know it's supposed to be around a neg 75, they're going to reduce the power to your miner. At least I'm pretty sure that's how it's working.
Okay. No, I think I can clear that part up. So up, like, as long as it's within the legal limit of, in the US, 36, helium won't reduce the power. I actually made this mistake on another YouTube video. I said they would reduce it. They don't reduce it. They just take it into account. So it goes into the RSSI equation kind of accounting, right? And they say, oh, this guy's got a 9 dBi and this guy's got a 3 dBi. This is kind of how these two things will see each other. This is the expected RSSI. It won't reduce either of those because both a gain of 9 and a gain of 3 still keep you under the US legal limit of 36. But if you put on, let's say, a 15 dBi gain antenna, now helium will, when you put that into your app, right? So helium can't detect what you're pushing out. So they're relying on us to accurately report what we have. When you say, hey, I've got a 15 dBi antenna on my hotspot, helium will say, okay, all of your transmissions will be reduced by 6 to get you down to the legal limit. So it's not on like a per transmission basis. It's when you update the antenna information in the app, then basically the app sends to your hotspot, hey, reduce your transmission strength by X to get down to legal limits.
And I guess this is another question I just thought of. What happens if you don't update your app?
If you don't what?
If you don't update the app. So let's
If you
say
don't
you
update
had,
the app, you'd be pushing out at a higher level. I mean, this is kind of good. It gets into stuff that is at the same time complicated and simple. So it depends on how deep you want to dive into it. And this is a great place to do it. So when I think about this, like where is the use case for asserting a different gain than you actually have? And it's pretty clear, like we're all trying to build a network. No one's trying to game. This video is being recorded on January 12th when there's a giant kind of gaming fiasco going on around Helium. We're going to set aside the gaming stuff right now and just kind of focus on the realities of RF and radio wave propagation. So a reasonable time to say, let's say you've got a 9 dBi antenna. It might be reasonable if you're putting it inside your attic. So it's inside an attic. You know that signal will get attenuated or weakened because it has to pass through the attic. And you also know that any signal coming into you also has to pass through the walls of your attic. You'd have to take a guess here, and really you'd have to test it. But you'd have to test and say, okay, the attic, it attenuates my signal at, for example, 1 dBi. So I'm going to assert a gain of 8 because I know that outside of the attic, that's what the gain will appear to be. Does that make sense?
No, it makes perfect sense. And there is, and I guess that's a good segue into something that I've talked to a lot of people about. Well, is a high gain antenna bad? No, it's not bad. It's there for a reason. All these higher gain antennas are there. They were invented. They were made for a purpose. Same thing with, and we can dive into the whole inline amplifier thing too. There's a reason that those are on the market, and it's not just to boost the highest power possible, because technically that's illegal. But all these things are made for a purpose, and they are utilized in the real world outside. Not that the helium is not the real world, but in other real world use cases that have been around for a very long time.
Yeah, so I mean, the layer that we've got on helium is that all of this is heavily driven by earnings, and so people are optimizing for earnings. They're not necessarily optimizing for RF coverage. One of the things I've noticed is that, I think we've talked about this in other conversations, is that even low gain antennas, even the H antenna, which is a 3 dBi antenna, that thing will connect with, will witness and receive beacons from over 200 kilometers away, over water, to be fair, over the Pacific Ocean. It's at just south of downtown San Diego, and it'll hit stuff up in Santa Barbara occasionally, and definitely up in North LA. So I guess a confusion point I have is why would someone use a high gain antenna if you're not really getting any extra, let's say, legitimate range? Like, it's already going 200K. How much more range do you need?
Well, and see, that's where it comes into kind of the hobbyist of, and let's backtrack, or not, let's go back in time. It's a better way to put it, of about a year ago, when at that time, the more witnesses you had, the better you were, or you wanted to, even today, it still makes sense to, if you want to get to a better transmit scale, a better area, and be witnessed by better miners or better hotspots in a better area. That's one way to think of it, but also the high gain antennas, you don't necessarily need them. And with helium, especially, you don't know if you don't need them until you test things. When you have consecutive people, I remember way back when we first all got together and you put up one of our antennas and you were using I don't even know, probably a 9 dBi or something. And then you were hitting LA, and it was, how is this possible? And it's because of the protocol that we use. Even as of this morning, a friend of mine in Colorado, he's crossing state lines. He's up in Evergreen. He's hitting Laramie, Wyoming. I mean, that's 143 kilometers away with an indoor antenna right on his window. Now, is that an everyday use case? Is that going to happen for everybody? No. But it's pretty remarkable that a very low gain antenna with, no afterthought of, here, I'm going to put it in the window and that's it, and it goes that far. It says something that you don't always have to have. You want the antenna outside. You want it to have elevation, but you don't necessarily need a high gain antenna.
Yeah. And I think on top of that, well, I guess then the question becomes, for me, if I'm thinking about this kind of practically, is if it's not a range question when you're going between a low gain and a high gain, is that basically you get the same practical range. Let's say it's 200 kilometers or less. Like, a high gain is not going to get you to go 600 kilometers just because of whatever curvature of the earth. So if 200 km over water, let's say 150 km over land is your practical max, I don't see a reason to use a high gain antenna unless you have kind of known attenuators in the way. That's the only time I see a reasonable reason. But for the rest of the time, if you're getting out your antenna outdoors and up high and there's nothing blocking, the pattern of a low gain antenna it just provides more coverage.
Correct. It does. It really, really does. And even to go, I guess, a little bit deeper into that, I've had a lot of customers write in and say, well, I switched antennas and it's flatline. I switched antennas and nothing is happening. It's not working. And trust me, I'm a victim of it too. Everybody wants things to work immediately and after an hour, after a day. Nobody wants to wait. Totally get it.
Yep.
But more times than not, even if you switch it without even rebooting your miner or turning off your miner, it may take a day to maybe 7 days to accumulate more witnesses and actually see what it's actually doing. There's not really a good other real world example of swapping something and saying, well, I didn't get the same results, but they're two different things. So it goes back to, patience is truly a virtue in this endeavor.
Yeah. And having testing tools, I think that's part of it is knowing that a Helium hotspot is not a testing tool, right? It's like, excuse me, Jesus, it's what is actually happening. But it's not like a Glamos where you immediately say, okay, I hit the button and I know that these packets went to these places because I'm immediately seeing that back. I'm not waiting on peer-to-peer stuff to update it, none of that stuff. So yeah, if you want to actually test it and get good results and have good signal to noise, you need to use testing equipment. A Helium hotspot is not testing equipment.
Right.
Okay, cool. So I think that covers the confusion we had with the high gain and the low gain, and when the power gets reduced and when it's just taken into account, which are two different things. You'd said something I want to clean up a little bit. Is it's due to the protocol that these signals can go so far? When you say it's protocol, what do you mean by that?
So by LoRaWAN, that long PHY / LoRaWAN, it's the same thing. Essentially, it's the same thing. And I've said this multiple times before. It's meant to go the distance, and it can travel very, very, very far, even obstructed. So, and I guess even to touch on before, we were talking about high gain antennas. There's nothing wrong with them, even if you're using one right now. Again, there's very little you can absolutely do wrong and don't do, or someone's going to come after you. It's going to break your miner. It's just trying to help people to answer questions as to what should you try, especially newcomers to everything. What should you try? What shouldn't you try? What have other people tried that is a fool's errand? That's try and learn from others instead of recreating the wheel that doesn't work.
Yeah. Well, let's talk about amps and splitters and multiple antennas.
Yes, so, a lot of people are excited about. They always have been excited about those, and in theory, those are all awesome things, and they do what they say they do, but they're not really good for what we want to do with helium. I guess we can start with the splitters first.
Yeah.
With the splitters, in theory, on a whiteboard, you're going to get the common scenario is using a high gain directional Yagi or sector antenna to get everything far away. And then you're going to be using a lower gain Omni to get everything close by. In theory, makes sense, checks out. But in reality, what you're doing, because the concentrators, the lower gain concentrators are only a SISO radio, means single input, single output. They're only meant to have one antenna. Multiple input, multiple output is MIMO antennas. That's when you see multiple antennas. And some people actually have gone online and seen, lower WAN gateways have two antennas for antenna diversity. It's not necessarily MIMO, but there is two antennas to get better reception, better transmit and receive. But that's not. It's lower WAN, but it's a different gateway device. So we'll stick to the single input, single output of what we're dealing with helium. And when you take a single transmission line and split that, there are some more expensive splitters out there that you can define. Okay, on the left path, it'll go 0.5 watts. On the right path, it'll go 0.5 watts. Typically, with the less expensive splitters, it's just throwing power out there, and you have no idea how much power out is actually going to each antenna. And
so it's not a 50-50 guaranteed split.
No, it's not. It's more of a better way to think about it. If you have like on the spigot on the side of your house, and you have a Y splitter, so you can have two spigots now. Are you going to have an even distribution of water in each spigot? And when you're splitting it, it
should be, but it might not be. Okay.
It'll be close, but you have no guarantee of what that's going to happen or how that's going to happen. Yep, Same thing with the receive. So both transmit and receive, you have no idea the power is coming in or going out. And a better way to think of it too, if you have a higher gain, if you're splitting it, just not even high gain or low gain omni or directional, you're only transmitting out at 1 watt or 36 dBm. So it's only 1 watt
36
out.
max. Yep.
So if you effectively think of that, you're splitting at 0.5 and 0.5 if it was evenly distributed. So you're having your power out automatically if it was evenly distributed. So you're kind of hurting yourself in a way, not even knowing it.
Yeah. So let's talk about the 2 or maybe 3 scenarios. The first scenario is the one you talked about. You've got a high gain and a low gain antenna. So let's say a 9 and a 3. And the 9, your intent is to reach far, and the low gain is to cover the near distance. Now, one problem I see with that, just with my 3rd grade math, is that one of those is 3, one of those is 9. What do you report to the app? Because you're still, as far as from the app's perspective or the Hotspot's perspective, you still only have one antenna. Like, it can't tell that you have 2 antennas on there.
No.
I don't think there's a reasonable way to do that. There are definitely ways to do that. And if you're a geek, you probably don't need to watch this video. But I think what I'm aiming for with this is like, hey, you're fairly new to Helium. You're certainly new to RF. Like, here's the basic concepts of how it works. And the first thing is that a splitter splits things maybe unevenly. So there's that problem. And the second thing is that if you've got these 2 different gains, there's no way to accurately report that. And both of those reported gains, if you split the difference, will be wrong. If you don't split the difference and you report 3, it'll be way off on the 9, and vice versa.
Yep, absolutely.
So cool. Anything else to add to kind of scenario 1 there, like a high gain and a low gain?
The only other thing that a lot of people don't think about is that having this scenario of a splitter or a high gain directional antenna and a low gain omnidirectional antenna, a very common way to do this, if you would think of an intersection and you have cameras in an intersection, and let's say a municipality wants to look at these cameras in this intersection, you'd want to have connectivity from, let's say, all 4 sides of the intersection. So you'd have an omni antenna to connect to those, but you also need a backhaul, which would utilize the high gain antenna, but you have 2 different radios doing those 2 separate things. They're bridged together on the backplane via Ethernet usually. But so the reason you do that is if they were all on the same frequency and on the same channel, you're providing massive self-interference. So that backhaul is going to be obstructed by RF self-interference. And with Helium,
okay, you got a lot of jargon there. Let me break that down. Hang on a second, Ben. Okay, so I think the point here is that, let's say a packet comes in from an antenna far away, and it's received by both your high gain and your low gain. If that packet comes in from both antennas and goes into the miner has a tough time saying, like, what am I doing here? Is that kind of the big picture, or is there something else I'm missing?
It would be more of, so when you have a hotspot and it transmits between 902 and 928 megahertz, right? And so there's several different channels on LoRaWAN that it transmits and receives on, but it's in that block of 900 megahertz. If you have one hotspot that has 2 antennas, but you're operating on the same frequency, but one is the low gain omni, so you're creating a big bubble around you transmitting on the same frequency you're trying to transmit out on the high gain, you're creating self-interference at the same point. So so this
is more for like a beacon, not so much for a witness. More for transmit, not so much for receive, or is it both?
Yeah, I would say more for transmit than receive, but it could be seen as both ways. You're still obstructing yourself, and then you could even go more into it of saying, well, you could use bandpass filters, but when you're filtering yourself, what are you actually filtering? It's kind of you're in a snowball of what's causing your problems is the splitter and using multiple antennas, and just get rid of that, and there's no more problem anymore.
Right. Okay. I think that's pretty reasonable to say that is probably not a great strategy.
No, it does. Going back to, will it work? Yes, it'll work. It's not going to be the best scenario for you.
Right. Yeah. Yep. But I think if you've got the ability to put the omni up high, like, that's where you should focus your efforts. Okay. Yep. So scenario number 2 is actually more reasonable to me, and I just don't do it. I don't recommend it just because it's overly complicated, but there may be other reasons to not do it. And that's that you have one hotspot. You got 2 antennas that are both directional antennas, and they're pointing on different sides of a building. Maybe you have 4 and they're on the 4 sides of the building, but for right now, let's say one's pointing north, one's pointing south. They're the same gain. They're both, let's say, 9 dBi sector antennas. So they're providing that coverage. I guess you could put 18 dBi as your gain in the app, and both would be they still get clipped because helium's not going to push out over 9 anyway.
Mm-hmm.
What are the downsides of doing kind of this north south or east west or whatever, like 2 sector antennas pointing different directions?
The first thing that comes to thought is what we first talked about of uneven distribution of power.
Mm-hmm.
You could also have reflection of power back into your miner, talking more about SWR or VisWar. So you don't know, again, you don't know what power is going out where. So you could have a reflection of that power coming back into your hotspot, which over time will destroy the concentrator or the radio card.
How much of a risk is that if we're pushing out? Let's say we say that we got 2 9 dBi sectors,
Mm-hmm.
and so we put in 9 in the app. I mean, how much of a risk is there that one of those? I just don't see that is a problem. Maybe I'm missing something. That one of those gets the full 9, which it would get anyway.
Yeah,
What am I missing?
it's not a plug in and everything blows up. It'll be something that happens over time. So again, it's not is it going to work? Yes, it'll work. But over time, you're not doing good things to the hardware that you invested a lot of money in.
Right.
I mean, sure, you could possibly get short-term earnings for that. They're much more lucrative, well, let's say a year ago. But for now, it's not, in my opinion, it's not worth the risk of throwing things into the transmission line that are going to do more harm than good.
Yeah, I'm 100% on board with you. I'm just trying to walk through the logic on it. So
Right.
I guess it wouldn't matter if you had 2 9 dBi gain antennas because that's the max you can push out anyway. But if you had 2, like, I don't know, 6
Mm-hmm.
sector antennas and you wanted them to get max power, so you mark your gain at 9, there's a possibility that those antennas could get more power than they quote should get, and that's when it gets reflected back. Or am I not understanding like how stuff gets reflected back or how the system works?
It wouldn't be what you actually assert in the app. It would honestly just happen. It's something you can't control.
Mm.
So it's when you throw things in the transmission line and you actually don't know what's happening, you literally can't control what is going to actually, if it's absorbed back into your concentrator or radio card, or if it's actually going out. You honestly don't know. You could measure it. It's probably going to take a while to actually figure out what data you're actually collecting is accurate. But it's not going to destroy the hotspot. If you plug it up and it's been working for 2 months, it's not going to destroy it in another 2 months. It'll happen probably in 6 months or something like that. It's not going to be an
Okay.
immediate, again, plug and play and things fry and everything goes to crap.
Right. Okay. So you could do this and not know right away that you're damaging your hotspot, but over time, let's say a year or 2 years, you're going to fry the hotspot is pretty likely with the splitter. Now, I'm guessing because I know that splitters are used in the kind of greater radio world outside helium. Is it just that you use a nicer splitter, or is there some other method of people use to stop this reflection and kind of destroying power?
You could use, well, there's just like anything that a lot of people have discovered, you can go and spend, $20 an antenna off Alibaba or Amazon, or you can spend $300 on an antenna. And you get what you pay for. And some of these splitters, you can actually go and actually define, again, like the left path will have zero point 0.3 watts, the right will have 0.7, things like that. And those cost several $100s. Do people want to pay that? I mean, if it's for a hobby for doing this, I personally haven't done it, but you can
Okay.
absolutely do that. But,
okay, so you could spend more money and you would eliminate that risk, but you're spending more money and I mean essentially you're just complicating things
that don't
unnecessarily.
need to be complicated.
Yep.
Mm-hmm.
Okay, so that's splitters. What about amplifiers? Because there's at least one use case where it's okay, but for probably 98% of people, it's not. Walk me through what happens there.
So back in the day, back in the before times, when you could have 200 witnesses and you'd earn off of all of those witnesses and you want to reach as far as possible, totally understandable. This is before POC 11, all that good stuff, when it truly was kind of the Wild West and we could transmit however hot we wanted to. There's nothing wrong with that other than you're technically doing illegal things. If you only have, let's say, 10 foot of coax and you have a 2-watt inline amplifier and you have a 9 dBi antenna, what are you really trying to achieve other than getting the furthest reach possible, which is completely understandable. But with now, if you're capped at 18 witnesses that you can actually earn off of, and I believe that's correct, right? You're
So,
capped at 18. Let's just say 18, and you already have 18 close by to you, and you're getting an extra 10 by adding this amplifier. There's no need to do that. there's not a need. If you were the one use case that I fully support of people wanting to put these on towers, and that's what amplifiers are used for traditionally. If you have a run of, for maintenance purposes, let's say you wanted to keep your hotspot at ground level, which makes sense because if something happens, you have to get a tower crew to climb up and take a look at the splitter that burned out or whatever the problem may be, or just simply rebooting it. You're going to put a 1 watt, 2 watt amplifier on that to make that 200, 300 foot run of coax make sense. That's really what they're used for. And they're used by cell companies, they're used by two-way radio companies. They're very, very common, and that's what they're there for, is to traverse long lengths of coax if you have those long lengths of coax.
When you're saying coax, that's antenna cable for us like non-technical people.
Yes. So the when people go on and say they get the LMR cable, the LMR 400, 600, things like that, or 200, that's the coax or cabling that I'm talking about.
Yep. Okay. Cool. And then what are the hazards of using an amplifier? Can it reflect energy back the same way that the splitter can, kind of, and burn your hotspot out, or is that not really a thing?
Yes. No, that's a thing. So we'll go back to the example of the 10-foot run of coax or LMR. It's a bidirectional amplifier, meaning it amplifies out and amplifies in. So if you are, let's say you got a 2 watt amplifier and you're transmitting out, you already have 1 watt at the transmitter. You do have some loss in the coax or the LMR, but you're adding on 2 more watts to that transmission line. Yep. It's a lot. It's for helium. That's a lot more power. Yep. Same thing with the receive signal. Once it hits that amplifier, it's receiving back, adding 2 watts directly back into your radio.
And that's the danger side, right?
Yes. Now, if you want to blow it up instantly, go get a 10 watt, go get a 15 watt, just put more power in there, and it's not going to last.
Make the magic smoke come out. Yeah.
But using a 1 watt, 2 watt, is it going to happen the first time you use it? Is it going to happen the first week? Most likely not. But over time, it's going to degrade the sensitivity to your radio card, and slowly but surely, it's just going to keep dying and dying until it doesn't work anymore. And then you'll be scratching your head, why did I do that?
Yep. Okay. Is there a calculation that you might use? Because I know people, and I never got into using amplifiers or splitters, but I can see the attraction is like, oh my God, more powerful is better. I want to get across this distance, whatever. Is there a calculation they might reasonably use to say, okay, it's time to use an amplifier, or it's not?
To seriously look into it, let me answer this as simply as I can. If you are in the realm of using, let's make the cap of 30-foot runs of coax or LMR. If you're going over that and you truly cannot use the PoE method of getting your miner outdoors, and you have to use a 30+ foot run of coax, it might be worth looking into using an amplifier. Right. Now, in doing that, you're going to have to, in a lot of these online calculators, you have your transmission power out, which is usually set at 1 watt because that's what everything unlicensed is regulated to operate at. Yep. You have to put in your correct wattage out, which would be, if you have 1 watt plus a 1 watt amplifier, that's 2 watts, or translate that into dBm. Off the top of my head, I don't know what that is, but or whatever power amplifier you have, yep. And then it'll say how long of a run of LMR 400 or 600, and it'll calculate what your EIRP out will be, and as long as that is within the realm of what is legal, then you're okay. So it's not it will take some playing around with to see what you actually need, which a lot of these deployments, if you're going on a cell phone tower, if you're going on a ham tower in your parents' backyard or wherever, it's not going to be as cut and dry of you buy this antenna, 30-foot run of coax, this miner, and you're good. That's it. There's going to be more homework to it.
Yeah, definitely caveats, because coax is not just coax. Like 400 is different than 600 or 800 or 240 or 195. So I don't know that I'd push out, or I'd push it on that idea that like just 30 feet is the minimum, because if you have 30 feet of LMR 900, you don't need an amplifier.
Correct.
Right. So most people are thinking, when they think LMR, they just put 400 behind it, because we're all so new to radio that it's like that's the only cable that we think exists, but it's not. There are thicker, lower loss cables. I'd say as a blanket statement is that 100 feet or less, you're just better off either getting a thicker cable or, like an LMR 900 or something that's lower loss, rather than putting an amplifier in there.
I'd agree with that.
Yeah, the cost might be a little bit more for the cable, but you're just eliminating a ton of complexity and potential problems. As you start to go over 100 feet, that's when I think it's reasonable to start thinking about an amplifier, depending on how you, yeah, what you're doing. And then the other thing I would think is just a very rough rule of thumb is you want to get the 27 dBm that your hotspot is putting out. You want to get that amount of power to the antenna, is how I would think of that. So if you're using lower loss cable and you've got a 3 dBi antenna, let's see, what's the way I think to explain this? Yeah,
are you gearing toward using a higher gain antenna with a longer run of coax?
I mean, I think that's reasonable. Like here's the thing with antennas is anywhere between 3 and 5.8 doesn't seem to make a huge difference to earnings from the experience I've had, right? You can use a 3, you can use a 4, there's a 5.8, there's even a 6. Like it doesn't seem in most cases that switching one out for the other makes a giant difference. Now, there's always an edge case, and I'm sure someone watching this will be like, well, my antenna, I jumped earning 6x. Like that's cool. There's 430,000 hotspots in the network. I've seen a lot of them. Might be different for yours, but for most of them, not a huge difference between those. One way to think about having an antenna up super high is you can kind of offset that loss by having a higher gain antenna, but you just change the pattern of that antenna's radiation. And so you can have less local coverage. Yeah. For these tower things, like, man, if you're doing tower climbing stuff, you're probably not watching this video. This is probably not the thing for you. In most cases, I try and keep your runs under 50 feet, use LMR 400, and don't worry about how much loss you have. You're going to have a great range anyway.
Yeah, it's when people get into the nitty gritty of it, it's honestly nitpicking of, well, I'm gaining 0.2 more dB in power, and that's what I want to do. And that, again, there's nothing wrong with that if you want to do that, but you're back to your point of, is there much difference between a 3 dBi and, let's say, a mid-gain up to 6 dBi antenna? I've had customers say that the 5.8s have done 1 HNT a month better. I can't predict that. It's every single deployment's different. That's the hard part about all this. It's the fun part, but also the annoying part is everybody has their own little world of how they're deploying and how to make the best of what they can do, of how they're using it.
Totes. Okay, so that's splitters, that's amps. My general recommendation is don't use that stuff. Don't mess with it. Unless you just like geeky stuff. In that case, have at it, but know that there are some risks. We talked about multiple antennas with splitters. I know that there's like a multiple antenna gaming issue that we're not going to cover here. Cover that in other videos. And then the last thing to talk about is the bandpass filter idea. I do get occasional questions about that, and to kind of paint that picture is that a bandpass filter is a filter you put basically, connected to your antenna and hotspot that filters out some of the signals around you. And you would typically use that if you're putting your antenna on a cell site where there are tons of other antennas that are blasting out either enormous amounts of power that are close to your frequency or far away or whatever. Like you're trying to clear out some of the noise from the signal. That's correct with the bandpass?
Yep, that's absolutely correct. And even if you can figure out, like, let's say you're on a rooftop in a major city and there's, 30 different antenna systems up there and you have no idea what they are. And let's say you don't have access to the equipment to actually sniff out what is actually being transmitted. What is it? Cell? Is it paging systems? Is it SCADA? Is it other helium? And you really don't know.
Yep.
If you don't know and you don't want to buy this stuff or find a friend or whatever to do it, put a bandpass filter in. It's not going to hurt you by any means.
Oh, really?
But if it's not going to hurt anything, because all it is limiting adjacent interference that's going to be over from 902 to 928. So if it bleeds over, it's making your hotspot only be concerned with what you're actually looking at transmitting.
Supposed to be. What's the cost of a bandpass filter? Like what would be a reasonable amount of money to spend on something?
Well, let me Google it. I don't know.
Stand by. Let me ask Googs. Yeah, I'm wondering if it's something that's reasonable for the average person to do. If it's kind of $50, if it's more like, hey, if you want to get a good one, you're going to spend $600. Like, I don't know. I haven't used those things. I've got a couple clients who have, and they've played around with it. I don't know if you and I were batting this white paper back and forth where they had said that you're far better off getting kind of 6 feet of vertical standoff from other antennas than using a bandpass filter, but you could use both without.
Yeah, it's kind of, you can dually attack it, for better lack of terms, and get that standoff, for better lack of terms, by 6 foot, and also using a bandpass filter. And even by just quickly Googling it, I've got some that are $200. I've got some that are $600. I got some that are $700. Now, does everybody want to spend that kind of money? I highly doubt it, because I wouldn't. And even with the filters, let's say you've had your hotspot running for a month and it sucked, and you have a lot of other antennas and things around you, and maybe worth looking into to try. You don't have to spend all the money. You don't have to spend $700 on a bandpass filter. You can, like this Elcom one. What is this? How much do you cost? It doesn't list the price, but let's just say it's $200. You're probably going to spend in the realm of $100 to $200 on a bandpass filter. I think. Don't quote me on that, because I'm sure people have found them cheaper. But again, it's not going to hurt anything to use one.
Right. Okay. Well, it won't take any power away. It won't affect the.
It's going to be minimal loss. It's not going to be like you're losing 2 dB, something like that.
Right. And that would be called insertion loss, right? Is like when you start putting things in line that is lost from lightning arresters or bandpass filters or whatever.
Right. But it'd probably be more beneficial instead of having a bandpass filter in, I would say, 80% of deployments than having actually having a lightning arrestor versus a bandpass filter. Sorry. So if you're gonna put insertion loss for something, having a lightning arrestor versus a bandpass filter would be better off, because you should have a lightning arrestor on almost anything that's deployed outside.
Okay. All right. That's a nice little PSA. Is you should put a lightning arrestor on.
You really should.
Yeah. And it seems to make it, I get that question a lot. And for your lightning arrestor to work, you got to ground the thing. You can't just put it on there and it looks pretty. And, that little tab is hanging off. I've got one right here. If this guy isn't connected to your ground, then this guy can't do its job.
Correct. And electricity does like to hurt things.
Yeah. It likes to blow up electronical things. Magic. Okay. Is there anything else? So we did splitters, amplifiers, bandpass filters. Is there any kind of geeky stuff that you're seeing? I mean, you guys are an antenna manufacturer. H Antenna is out of Ohio. So it's American-made antenna. Super good stuff. I use it on all mine. You guys must get a boatload of calls about RF geekery stuff. Is there anything else that you guys see? Because you field most of the phone calls, right? That's a commonly asked question.
I would say 100% of them. If you give us a call, I'll pick up the phone if I can. If not, I promise I'll call you back. But a lot of it is entry level stuff, which again, there's no question is a stupid question, especially if you don't know. RF, wireless stuff, networking. Nobody learns it overnight. It can be very complicated. If you feel dumb about what kind of connector type is this, don't feel stupid. Because I was there at one time and I didn't know the difference between an N-type connector and an SMA connector. I had no idea. So don't feel stupid with questions. The good thing about this community, for the most part, is everybody's here to help each other. The people with knowledge like to expel the knowledge. We want to help. So
cool. Is there a question that you answer like 5 times a day?
What connector type do I need? And more times than not with an antenna, not just our antenna, but like the Elcoms or the racks or the Mcgills, they usually have an N female type connector. So your cabling that you're going to need to get for an outdoor antenna is going to have an N male. And I would, and correct me if I'm wrong, I would say 97% of the hotspots out there have an RPSMA female connector. So your other end of your cabling to connect to your miner is going to have to be RPSMA male.
Yep. And I've got a connector. I think it's called What Connector is the link on my site. But even after having put up a ton of these, I will still pull that thing up on my screen and like point at it, be like, that's what I need. And this is what I have. And I'll be looking at my hotspot. Like, sure, you feel kind of dumb, but if you get it wrong a couple times trying to not feel dumb, and then you're just like, you know what, I'm just going to do this paint by numbers, step by step, and get the right thing. Because I've got at least 4 cables in my garage that I ordered the wrong thing when I was starting. So,
and I guess the other question too that we get a lot of, and I don't have a problem helping with, but it's, here's my hotspot, here's my location, what do I do? And for the most part, there is some work that goes into deploying these things, and we don't have all the answers because we're not there with you. So
Right.
it is a case by case scenario. And I mean, even like we did way back when all this started, of
Yep.
what gain antenna do we use? Is it a 3 dBi? Is it a 9 dBi? Is it a 23 dBi sector antenna? But we did a
Yep.
lot of trial and error and a lot of testing. And it's now, I'm not calling people lazy. It's just you've got to test and you've got to figure out what's best in your scenario.
Yeah.
We can point you in the right direction, but there's no guarantee that if my 3 dBi antenna works fantastic for me in my attic, and you're in an attic in LA, is it going to be the same? It's not. And there's
No.
no way to see what would be the best other than trial and error.
Yep. Yeah, you got to test the stuff for sure. I
Mm-hmm.
remember I was surprised when I came out there and we're looking at just the local topography and the trees and everything. I was like, oh wow, you guys have a really different RF environment than
Yes.
Southern California, where we just don't really have the trees, the same kind of organic cover that you have.
Mm-hmm.
So cool. Dig it. Ben, thanks a ton for your time. Really appreciate it. If you guys like this conversation, you want to support what Ben's doing and help people out, it's hntenna.com, hntenna.com.
Yep, that's it.
Yeah. It's cruise over there and pick up an antenna. That's what I use on pretty much all my deployments right now. I think I've got one or two that I still have to switch out, but they're great antennas. They're not perfect. They're not a panacea. They're not like a perfect cure, but they're a great start. And I think to me, it was one of those things where I said, hey, I just don't want to worry whether or not I've got a good antenna. I'm not super motivated by getting the cheapest deal. For me, I'm way more like, I just want a high quality antenna. Are there places where a higher gain antenna will work better? Of course, right? The world isn't the same all over the place. But if you just want to get an antenna up there and you want a good one, I think they're a great provider. Yeah. Anything else before we wrap up? We good?
We're good. Everybody have fun and call if you have questions. I'll be here.
All right. Right on. Thanks, Doug.
All right. Thanks.